Hi everyone, today we're going to be starting on section 9.2, which is about hyperbolas. Before we head into that section though, let's just review quickly the two that we've talked about already. We've got circles, which of course looks like a circle. And the function for that was x squared plus y squared equals my radius squared as well. Key features of the circle, both x and y are getting squared. They are getting added together. There is no fractions involved, and it equals a perfect radius squared every time. Then we talked about an ellipse, which can look two different ways. It can go left and right, as well as up and down. Remember, an ellipse is similar to a shape of an oval. The function for that was either x squared over a squared plus y squared over b squared, and that always equals 1. Or you can take your denominator, a squared and b squared, and they flip-flopped, depending on the shape of the graph. Remember that your a squared, when paired with x, tells you that it's going to be the bigger number. Your major axis paired with x is going to make you run left and right. Whereas your major axis, when paired with y, when a is paired with y, it is going to make you go up and down. I mention these features because it's going to be very, very similar in our notes today. So it's nice to kind of pinpoint things that are alike throughout all of these functions, and of course things that are different. All right, so when it comes to a's and b's, the bigger number on the denominator, again, you'll see today, is going to be the major axis. It's going to tell you how that graph is going to open up, which directions. All right. And again, remember, it's always equal to 1 for an ellipse, and we are always adding both our x squareds and y squareds. Okay. Similarities between circles and ellipses, and now we're going to see similarities between ellipses and today hyperbolas. So go ahead and clear this off. You can take a look at the graph of a hyperbola. It is actually very similar to an ellipse. It's actually just reversed. So if I were to think of an ellipse one more time in comparison to this graph shown, an ellipse would look like this. And essentially, if we were to take that ellipse and split it in half and then convert it, it's going to look very similar to the graph you have here. Okay, so really, it's still going to make an oval. It's just going to make an oval going in opposite directions. They're not actually going to touch one another. We've talked about parabolas in the past when it comes to quadratic functions. And of course, a hyperbola we're going to talk about. And it's going to be two parabolas in a nutshell, essentially. Two parabolas, same kind of idea, but we're talking two. So, taking a look at this picture, we don't need to know all of the details necessarily, but some things that we have seen that are going to come up again. We have this center point. We'll notice we'll have centers again. All right. We're going to have vertexes, which is going to be the starts of our parabolas. And we are going to see foci one more time when it comes to hyperbolas. And on top of that, we are going to introduce a new point, because on this one, we can't graph coordinates, or we can't graph our hyperbolas unless we know a couple more points in order to get that function going. So that'll be done for us today. And we'll also introduce a rectangle, which I guess is actually not in reference to the focus. It's going to be in reference to the vertexes. So it's going to go here. Okay, all things that we will discuss in our notes today. So let's get started. Taking a look at just the generic form, the standard form of the two equations, you'll notice this time, instead of a plus sign in comparison to an ellipse, we now have subtraction. All right, that is the key detail in determining that we are in fact working with a hyperbola. We are now going to have subtraction. All right. Again, pay close attention. We have a squareds and b squareds once more. The a squareds, again, when paired with x, is going to tell you that you are working along the x-axis. And when paired with y, that tells us we are working along the y-axis. So to get started, when I say we are working along the x-axis, that is going to have a new name. That's going to be the transverse axis. Okay, and again, since it was paired with my A, that axis is going to be the x-axis. Whichever number is paired with the bigger value in terms of a hyperbola, down below will be our x-axis. So what we're going to do is I'm going to go ahead and, again, like last time, I'm going to just graph a hyperbola here, going 5 units out. Again, arbitrary values. This will be A0. I'm working on the x-axis because A is paired with the x value right now. So I'll, again, arbitrary values, but we'll just say 5 for now. Those are going to be my vertexes. All right. Then I'm going to go up 3 units as well as down 3 units. Again, arbitrary. These are going to be my B's, so they are labeling my Y's. Those are going to be my co-vertices, just like last time with an ellipse, except this time, instead of connecting all of my circles and making my ellipse, because we have a subtraction sign, we know we are working with a hyperbola, and what that is going to do is it's going to create a rectangle. Instead of combining all these and making an oval, we are going to just make a dashed rectangle. And what that rectangle is going to do for us is it's going to now split and diagonalize so that I know how to make my graph. Again, these are all just dashed lines just to give me an idea of how it's going to look when I go to graph my hyperbolas, excuse me. Now that I have my rectangle and my my asymptotes set up, I am going to now be able to graph my hyperbolas. Going back to the original, I have x squared over a squared. So a squared is paired with x. I know I have to be on the x-axis when I finish my graph. So I know I must be going left and right. So what I'm going to do is I'm going to come in from this asymptote, touch my vertex, and then I'm going to go back out. So what those asymptotes are doing for me is they're telling me how wide my graph is going to be. And as soon as I do one side, I get to go straight across and do the other. And that will be our hyperbola. The main thing I am focused on at the end are these parabolas, the sideways parabolas, and how they start, where they start, and so forth. All right. So to get started, or to finish off this, we're talking vertices. We will have exact coordinates for those vertices, and in our case, it's going to be plus or minus a, followed by 0, again, because it landed on the x-axis, assuming our center was at 0. That's another thing we'll have, just like last time, is a center point. We'll talk about that in the next couple examples on the next page, but yes, we will have a center to go off of, followed by our vertices, which are going to take us left and right in this example. After our vertices, we then have our co-vertices. So if we already took care of left and right, then we need to worry about up and down. So that is going to affect my y coordinates. And last but not least, just like when we talked about an ellipse, we had foci. Well, guess what? Hyperbolas have foci also. The difference in this function, though, is last time with an ellipse, we had c squared equals a squared minus b squared. But with a hyperbola, we're going to have a squared plus b squared. This is a significant change because we are adding on this one. So when we have a hyperbola, we are going to add the foci. Add the a squareds, add the b squareds. If you need one way to remember that, I kind of use the function itself as a hint. So the function for a hyperbola tells me I need to use subtraction, but when I get to the foci, it's got to be the opposite. I'm going to need to do addition. Same goes for an ellipse. The formula for an ellipse tells me I have to use addition, but when I get to the foci of an ellipse, I must use subtraction. So think opposites when it comes down to that. All right. And again, since the foci on this example, since the transverse axis is the x-axis, then that tells me that the foci are going to land on the x-axis as well. So this will be coordinates, go back here, plus or minus c, comma, 0. The coordinates on this one are pertaining to the center point. So there's no a involved. You are only working with c, plus or minus c. And, well, I guess in this case, there'd be minus c here and a plus c on the right. Okay. And last but not least, we also have something new, which we already labeled on our graph. We have the asymptotes, those dashed lines that went straight through those that rectangle that we created. Well, guess what? There is a function for those asymptotes, and it is all based off of the things that are given. So they're obviously a line, so we're going to say y equals some sort of slope, and that slope is determined by our rise over run. And for this example, our rise was our b value, and then our run was our a value. Think rise meaning your y's, running meaning your x's. In this case, since my y's were going up and down and my x's were going left and right, everything that went up pertained to b, everything that went left and right pertained to a. And last but not least, since my asymptotes are going in both directions, it's going to be both the positive and the negative versions. And of course, it's representing my slope, so I need to put an x with that. Okay. This is one for me, for example. This is something that I have to just kind of graph, and then I can determine the asymptote. But if you can remember the formula based off of where A and B are placed, then that is fine as well. So the difference between the first graph and the second graph is all in the way the picture will look. The first graph had us opening up left and right, whereas this one will have us opening up and down. And the reason for that is because our A's and our B's are now paired with different variables. My a squared is now paired with the y squared. Therefore, my transverse axis, the main axis I'm going to be working on, this time is going to be the y-axis. So again, I'll go ahead and label some arbitrary values here. I got my A's, but this time they're going to be labeled on the y-axis. 0a and 0 negative a. And then the b values are going to be on the opposite axis, and of course they need to be smaller this time because a is the bigger value. So we got b0 followed by negative b0. This is not an ellipse, so I can't connect my dots. I have to actually draw out a rectangle. Once I have the rectangle drawn out, I can then label my asymptotes, going straight through my rectangle diagonally. The reason for this, again, is to show me how wide or narrow my graphs, my hyperbolas, are going to be. And before I get to the foci, I get to graph my hyperbolas. This time I need to be graphing the y-axis, as that is my transverse. So my vertice, or my vertex, is going to land on the 0a and go back up. And then it's also going to come in and hit 0 negative a and go back down. And last but not least, we will have our foci, and this time they will land on my transverse axis, which is the y-axis. Always using the letter C from the center. Key points, again, we have a center point. In this case, we had 0, 0, because there was no changes, no shifting. We're going to have vertices where our hyperbolas are going to touch, and that is the y-axis. So we got 0, comma, plus or minus a this time. The co-vertices If A is taken care of and that paired with Y, then I have my B, and it's got to take care of my X. Followed by my foci, which again, we're talking hyperbolas, so the function to find your foci is c squared equals a squared plus b squared. And that will give me those coordinates. And last but not least, we have our asymptotes. It's going to be a function, a straight line function, but we have to pay close attention to our rise over run. This time, my a value paired with my y. So that tells me that my rising has to go with a, as rising pertains to up and down, and that is my y. So a goes first, divided by my running value, so left and right, which paired with x, so that is my b. So there is a change there compared to the first graph. My asymptotes in the first graph had plus or minus b over a, whereas my asymptotes in the second graph had plus or minus a over b. And again, if we don't know how to find those or we don't remember the function, just stick to the basics. If I were to find the slope of this line here, starting at 0, 0, I would do my rise. Let's use a different color here. I'd do my rise over run to find the slope. And if I did that, it would pair with my a value going up and then my b value moving to the right. So that's an easier way, in my opinion, to figure out your asymptotes if you were asked for them. So let's go ahead and take a look. What if we introduced a shifting point? What if we introduced h's and k's? And this is honestly the same exact idea as the ellipses. The only difference is we now have a subtraction sign separating the two fractions. Still equals 1, still has an a squared and a b squared. Both of those values are going to determine my vertexes and my co-vertexes, my vertices and co-vertices. And then I have my foci, which in this case is slightly different than the ellipse, as my function is a plus instead of a minus. And last but not least, I will also introduce asymptotes. So I'm not going to go ahead and graph anything. I'm not going to give an example. We'll do those on the next couple pages. But again, just some things to think about. On this case, my center is no longer 0, 0, as I'm introducing an h and k value. H is always paired with x. K is always paired with y. My vertices, pay close attention to where that a value is getting affected. It is working with the x. So if I had an actual center point, I would have h, and then my a would be affecting my center point as a plus or minus a, and the k will stay. When I get to my co-vertices, however, now that my x is taken care of because I've talked about a, now I'm going to keep my h the same, and my k is going to get affected, but not by a, but rather by b. Again, because my y value is paired with k, and in this case, k is also paired with b. After that, I'm going to go ahead and find my focus, or my foci, to make it plural, using the formula c squared equals a squared plus b squared. And once I have that value, again, remembering that I'm working left to right for this graph as a squared is paired with my x, that is going to make my focus also change my x value. So I start with the original h from my center, plus or minus my c value from my foci formula, and k will stay the same. So foci are only affecting whichever axis your original graph is landing on. And last but not least, I have my asymptotes. It's always going to be a function of y equaling a plus or minus some slope followed by x. And your rise over run for this example, again comparing your y over x, is going to be b over a. Plus or minus b over a. If I had a little bit of a shift going into the next section, this time you'll notice a squared is no longer paired with x, it is now paired with y. So that is going to change ever so slightly a couple of things. My center point is still going to be still going to be hk. But now my vertices are working on the y-axis. So my vertices, my x will stay the same, but my y will now be shifted plus or minus a values. Because the a is the bigger number, it will always shift the a, whatever letter is paired with a. Then I head into my co-vertices. If a is already taken care of, then b I look to, and that is going to work with x. So then my h value from my center is going to change by a plus or minus b, and my k will stay the same. After I find my vertices and co-vertices, using my foci formula, again, just to reiterate, c squared equals a squared plus b squared. This time my transverse axis was along the y-axis, so my c value that I find from that formula is not going to affect my center point for x, it's going to affect my center point for k, my y. So I'm going to add or subtract my c value to my k, my y coordinate of that function. And last but not least, I have my asymptote. It's always a function of y equaling a plus or minus version with x. And in this case, my rise over run was flipped, as my a value is now paired with y, and my b value is now paired with x. So some key features of a hyperbola. Things that make a hyperbola unique from the rest. We have the function x minus h squared over a squared minus y minus k squared over b squared always equals 1. Or I can flip-flop and say y minus k squared over a squared minus x minus h squared over b squared. So because we introduced a minus between the fractions, the a squared and b squared are always going to be in the same position. It's just a matter of swapping out the y and the x. Okay, in order to keep that detail unique and say you're subtracting every time for a hyperbola, we're not going to move the a squareds and b squareds, we're only moving the numerators. Okay, if I were to have moved the a squareds and b squareds, technically that would introduce a negative in the first term with a positive on the second term, and that's just not going to be the same every time. That's going to be one of those really extreme details I'm going to have to pay close attention to. So if you ever see a negative in our work, if we ever see a negative out front here, and then this was a plus sign, that will just tell me that that looks kind of weird. I'm not used to seeing a minus as my first value, especially with a coefficient. So I'm going to flip-flop those to put it a positive first, followed by a negative. All right. Now, the way we work out our math, it won't necessarily come up all the time, but I just want to discuss those details. All right. So looking at those functions, things to talk about, we will always use subtraction, so always subtracting. Always equal to 1, which is something we saw last time on ellipses. Our foci formula is new this time. It's going to be c squared equals a squared plus b squared, so I have to remember that's a feature of a hyperbola. I'm always going to have fractions for x squared and y squared. You can choose to put that down if you'd like. And I'm always going to have a center point. That is unique as well. And that center point is still hk. And again, just to reiterate from the ellipse as well, a squared is always the biggest. And actually, I'm going to take that back. A squared is not always the biggest for this example. A squared is actually going to be first. So that is something that's a little bit different. It doesn't have to be the biggest this time, but it does need to be first. Whatever one is first is going to make that graph tell me if I'm going left and right or up and down. All right. The reason why it's not first for an ellipse is because I'm adding my fractions, so that doesn't necessarily matter. But since I am subtracting, then yes, a squared will have to always be first. So let's try some examples. Taking a look at question 1, it wants us to graph it for sure and list my vertices, covertices, and foci. I am also going to add in those directions that we want to also list our asymptotes. Just because that is a key feature of a hyperbola, so if you see the word asymptote later on, that will tell you, hey, I'm working with a hyperbola. To get started on this problem, 9y squared minus 4x squared equals 36. Again, my features of a hyperbola tell me they have to equal 1. So right now it does not equal 1. That doesn't mean I stop. That means I try to get it to equal a 1. So I'm going to divide everything by 36. That will give me a new function once I simplify my fractions. Y squared over 4 minus x squared over 9, which will now equal 1. Okay, now pay close attention. I said a squared, again, not the biggest, but now the first. It's the first fraction, the first denominator that you see. So because we're working with a hyperbola, we're going to identify that my a squared is 4, which will make my b squared 9. Okay, not a negative 9, just a 9. So let's go ahead and figure out my key features. I have a center point, how it is shifting by h and k, and unfortunately I don't have an h or a k, so my center is going to be at this origin, 0, 0. My vertices, once I know something, let's go ahead and put it on my graph. My vertices are going to be along the y-axis. So I know that my transverse axis is going to pertain to y because y is matched with my a squared and it is the first term. So my graphs now are going to be going up and down. Just making notes here so that we can get that process in and keep thinking about key things. Now that I know it's going up and down, we will also notice that a squared is 4, so that tells me my a is 2, and my b is 3. That being said, that's going to tell me that my vertices, the main vertex of my hyperbolas, is going to be plus or minus, actually it pairs with y, so it's got to change my y value. It's going to be 0, comma, plus or minus 2. 0 being at the origin, plus or minus 2 tells me to go up 2, down 2. Those are going to be my vertexes of the hyperbola. Then I have covertices. I just took care of my a value pertaining to y. So now my vertices are going to pertain to my x value with b, and that's going to be a plus or minus 3. Right? So again, I understand the bigger of the two numbers this time was b. However, with a hyperbola, we're always just noticing that a squared is whatever fraction, whatever denominator is first. So as soon as I have these values, I'm going to make my rectangle. Once I have my rectangle, I'm going to go ahead and label or graph in my asymptotes. Doesn't need to be perfect. All this is just going to tell you, again, how wide or narrow your graph, your hyperbolas are going to be. And now that we have this information, I can go in Knowing that my graph is paired with y, my transverse axis tells me my graphs need to go up and down. That tells me that I'm going to come in, touch my vertex, and go back out. I'm following the lines of my asymptotes. I took care of the one going up, so now I'm going to do the one going down, come in, touch the vertex, go back out. All right. So the last thing I have for my graph that I haven't labeled yet is my foci. So using my formula, c squared equals a squared plus b squared. Plugging in the values that I've labeled, my a squared was 4, my b squared was 9. I know that my c squared is going to be 13. I'm not looking for c squared though, I'm looking for c, so my c is going to be plus or minus the square root of 13. What that means is from my center point, I'm going to go up and down, following my transverse axis, going to go up and down square root of 13 units. Now you can do that in your calculator to get a rough estimate. It's going to be more than 3 but less than 4. So from the center, you're going to go up and down roughly, let's say 3.5 units. And we're going to plot a point. And you'll notice that your foci are both inside your hyperbolas. All right? Pay close attention. It needs to go from the center out to your foci. If I were to graph and look for those exact coordinates, those coordinates are going to be at 0, comma, plus or minus the square root of 13. Remember, you're working off the center point, so the center was originally 0, 0, and your foci worked from the y coordinate. So you're adding and subtracting square root of 13 from the y. And last but not least, following the directions, I also need the asymptotes. So I'm going to put those in. The functions for those is going to be y equals plus or minus my rise over run. Well, my rise was 2, my run was 3. So it's going to be 2/3 x. All right. Go ahead and try question 2 now. See how we do. Pause the video if we need. Okay. Again, you have the teacher notes to go off of for this one, so I'm not going to graph it, but I do want to take a moment to explain a couple things. Again, hyperbola, how do we know? Because of a minus sign. And it is equal to 1, so the equation is set up nicely for us. Because it's a hyperbola, the first number is going to always be my a squared. The second number is going to always be my b squared. That being said, since my a squared is matched with my x, that tells me my transverse axis is going to be the x-axis. So when I get to graphing, my hyperbolas should be left and right. Those are the two directions they should be opening from each other. If I got my points for my center, it's your HK. Remember, those are always opposite. So my center is at 2, 3. Then I go into my vertices, the vertexes of my actual hyperbola, remembering that it is paired with the x-axis. So my vertices are going to shift from the center left and right. So it's going to affect the x-coordinate starting at the center and moving an a value of plus or minus 4, where the k value stays the same. If you wanted those real coordinates, those are going to be 6, 3 and -2, 3. Then we will go into the co-vertices. This time the covertices pertain to my b value, so my center of 2 on my x will stay the same. But now my y value is going to change by my b, which is plus or minus 3. Again, if you want those exact coordinates, we got 2, 6 and 2, 0. Looking for my foci, we have a squared plus b squared, so 16 plus 9 is going to give me 25. When I take the square root of 25, that's going to give me plus or minus 5. Again, since we're working on the transverse axis in comparison to the x, that is going to shift my center point. Starting at 2, it's going to shift the x-coordinate plus or minus 5, with the y-coordinate staying the same. And if we want those values, those are going to be at 7, 3 and negative 3, 3. And last but not least, our asymptotes. Always y equals plus or minus our slope and then x. And in this case, our slope, our rise over run, is my y over x, which was b over a. So we have 3/4 for my slope. All right. So that will be for graphing a hyperbola. Now, if I wanted to write the actual function for a hyperbola, you might see a question like this. Now, again, this information may not be told to you on the test. I may completely hide the fact that you are, in fact, working with a hyperbola. What you need to make note of is the vocabulary that is getting used. We have a center point. Well, a center is inside of a circle, inside of an ellipse, and part of a hyperbola. So that doesn't do much for us. Then I say that our focus is negative 2, 6. Well, the only time I ever see a focus or a foci is with an ellipse and in a hyperbola. So we eliminated a circle from the option. And then I also tell you that the vertex is negative 2, 4. Unfortunately, we still see a vertex on an ellipse as well as a hyperbola. So how do we tell the difference? We've narrowed it down to a hyperbola or an ellipse. When in doubt, graph it out. All right. Label our center point. We got negative 2, 1. Working right there. Our focus, negative 2, 6. Negative 2, 1, 2, 3, 4, 5, 6. And then our vertex is negative 2, 4. And here is where we see it. Okay? The vertex is this last point that I just plotted. I know that a foci or a focus has to be included inside of my picture. So if I were to make an ellipse, the only way to make an ellipse right now is I have to include a focus, the vertex, and the center. Well, the only way to make that happen is no way. Okay, I can't go from the vertex through the center and back through from the focus. Okay, that cannot happen. However, I can draw a hyperbola knowing that it has to include the vertex, which will include the foci, and all I would have to remember is that if I do it up, then the other option would have to go down. So I don't know anything about the information going down, but I know enough now to know that it is a hyperbola that we are working with. And in fact, that hyperbola is going up and down. Therefore, my coordinate that needs to go first is my y. So I go ahead, I'm going to write out my function. I know I'm starting with y. I'm subtracting. Then if I have y, then my next one's going to be x. And it always has to equal 1. So now let's go ahead and fill in the center coordinates. Well, negative 2 has to go in with x. remembering it's got to be the opposite. Technically, it would say x minus a negative 2, which will make it a plus. And then y minus the 1. All right, so all the numerators are taken care of. Now I am left with finding the denominators. So I need to know my a squared as well as my b squared. Your a squared is always going to be from the center up towards your vertex or your vertices, and then we have to square that. So if I were to count from my center up to the vertex, I have a total unit of 3 units. And when I square that, I'm going to get 9. That 9 is going to fall underneath my y minus 1 squared. The last bit of information I'm going to need is my b squared. Unfortunately, I don't know any information that falls on the left or the right of my functions, but I do, again, I know my a squared, and I also know my focus. My focus is a total units of, let's see here, 5. So when I square that, it's going to give me 25. So I know that my c squared equals 25. I know my a squared equals 9. So if I go and I use my function for the focus of a hyperbola, c squared equals a squared plus b squared. If I plug in the things I just found, 25 and 9, and I solve for my b squared, I will get a 16. And that 16 is what I was looking for to find my function. Remember, we needed b squared, not b, so there was no need to do the square root. So again, keep that in mind on your test. This hyperbola statement may not be there. So use the hints. When in doubt, graph it out to get an idea of what we are actually working with. The last 2 questions here, we're talking about completing the square just like for an ellipse. Again, we're going to assume at this moment we do not know that this is a hyperbola. So we're going to still attack it the same way we would if it were an ellipse as well. We will worry about the hyperbola portion in just a minute. Okay, and again, you will see what I mean by that, like I mentioned at the beginning. So to get started, just like last time, we're going to make sure that all of our variables are grouped together. So all my x's are in the same area and all my y's are in the same area. That is done for me, so I'm happy there. Then I'm going to factor out any coefficients that the x's and y's have in common. So when I look to my x's, I can factor out a 4, leaving me with an x squared minus 6x. And then when I look to my y's, not only can I factor out a 25, but I'm going to also factor out a minus 25. And that's going to give me a minus 10. Y, who lost the y, equals 489. That 489 is a weird number. Yes, you are making that, you are seeing that connection. So that 489 is going to change down the road here in just a minute. Right now I have an x squared minus 6x in parentheses and a y squared minus 10y in parentheses. Well, in order to get those parentheses to go for me to find my actual center point, I need to complete the square. Remembering that function, it's always b over 2 squared. Your b value is that extra piece in these parentheses. So if I did b over 2, I'm looking at negative 6 over 2 squared. That's going to give me a 9. Worry about that in just a moment. I'll do the same thing with y. I got negative 10 over 2 squared, and that is going to give me a positive 25. What that is going to tell me is I'm going to keep the exact same thing. Notice how I'm keeping colors the same as I go through here. I'm going to keep the exact same thing I had up above, but now that I just completed this square, that's going to be the value I add in with those parentheses. Keep the minus 25, keep the y squared minus 10y, and I'm going to add 25 to this parentheses. And it still, at this moment, is equaling 489. Now, I can't just add things willy-nilly without also doing it to the other side. So what needs to happen is I have to figure out what did I truly add, oh my goodness, what did I truly add to the left side? I added a 9, I added a 25, but I have those coefficients out front that are going to change it just a little bit. So I didn't really add a 9, I technically added a 36 when I have that 4 out front. And I also technically added negative 25 times 25. I added a negative 625 into the picture. So I have to be sure that I also do it to the left-hand side. Whatever I do to the left, or the right-hand side, whatever I do to one side, I have to do to the other side. Every single time. Now let's go ahead and factor. The whole reason we did this is so that I could be able to factor. When I factor, I'm going to get 4 on the outside, x minus 3 on the inside squared. There we go, there's the center point for x. Minus 25, y on the y minus 5 squared. And it is now going to equal a negative 100. All right, almost there. I see the center points, I just don't see the true function. So I'm going to divide everything by negative 100. And this is where it can get tricky. This is going to give me an x minus 3 squared. And in the denominator, I'm now going to have a negative 25. On this next term, I'm going to have y minus 5 squared. And in the denominator, I'm going to have a positive 4. The fact that I have a positive 4 now tells me I'm no longer subtracting those fractions. I am actually adding them. And it equals a 1. Okay. But the other note that I have to notice is my denominator down here is a negative 25. And that's the exact same thing as if I took that negative and I put it up here. It's still the same fraction. It's still telling me it's a negative fraction, but this is not the formula for a hyperbola. In order to make it the formula for a hyperbola, I have to take this chunk and put it as my second term. And if I do that, that will officially give me the hyperbola's function. I have a positive fraction to start and then a negative fraction at the second fraction. So I know that this is in fact a hyperbola. So even if the directions didn't tell me I had a hyperbola, I know at the end I created a hyperbola. So I'm going to leave you with question 3. Try this one on your own. Again, make sure all of your variables are on one side where the other constant all by itself, the number by itself, is on the other side. That's where you should start, is taking that negative 63, moving it to the other side, while also grouping your variables. Okay, it doesn't matter if y is first or x is first. You will make that decision at the end when you see which term actually truly has the negative coefficient or the negative denominator even. All right, so try question 3 on your own. Take a look at my teacher notes if you need and ask us